Hey guys, welcome back to Digital Srini channel on YouTube, and if you haven't already done so, please hit the subscribe button right now. In the last video, we deployed a Flask-based application, which is like Python-based, of course, into the cloud using Heroku. And that was a rather simple application, I should say, where we did a linear fitting for X and Y, and we took the pickled model and we started predicting, and the prediction was just a bunch of numbers. So the training was on structured data and the prediction was a number, and we looked at how we can go ahead and deploy it in the cloud. Now let's step the game up a little bit. Now what if you would like to use deep learning and you have, for example, Keras and a model saved as H5 file, and now you want to deploy this in the cloud and you want to use that trained model to do some predictions based on the image supplied by the user. So now we need to figure out, okay, the user is supplying an image, so we need to store that, and that image need to be supplied as an input to our model, so the model can do model.predict and give us exactly what the prediction is. So the application I'm looking at is a skin cancer lesion classifier. I have done a video on how to train, so I'm not gonna spend time talking about how to train this for HAM 10,000 dataset. I'll provide you a couple of links for my YouTube links where I have already done that. So the goal here is take the trained model from that exercise and deploy it in the cloud so the user can select upload a file, hit the submit button, and it returns the image along with what the prediction is. So that is the goal, and of course we are going to use Python and Flask and Heroku for our web deployment. So let's jump into the code. Okay, so here are the files. Oh, sorry, let me clear. This help thing always irritates me. So here are, where is it? Here are the files that we'll be looking at. So app.py, again, if you watched my last video, you know exactly what the intention, what the goal of that file is. And proc file requirements and runtime. I'll again talk about these when we get there in a minute. And main.file is the main part of my code that actually does the prediction. So this is one addition that I did not have in the last video, because in the last video, it was a very simple application. Under templates, of course, we have our index.html. In addition to that, I have a folder called static. And of course, a folder model where our model is sitting, the HAM 10,000 that I trained for 100 epochs. So this is the structure. And of course, this one is just when I was experimenting, I meant to delete it, but I tried to keep old experiments so I can learn from where I failed. Okay. So these are all the files that we care about, and example.jpg, this is literally something I Google searched and downloaded like an image, and I wanted to see exactly how, if we can classify that. So this is just a test image. So let's start by looking at main.py, because this is where I'm pretty sure most of you can easily relate to. It doesn't involve HTML, nothing. It's just a standalone file that does the prediction. Okay, so here are the two videos where I have already recorded how to train this HAM 10,000 dataset. And then that will give you the H5 file. That's the one that we're going to use for prediction. Okay, so first of all, there are 7 classes in this dataset. These are the 7 classes. So our image, whatever image we upload, is going to be classified into one of these. And when I train this model, of course, I resized the image and I did some pre-processing. So I have to follow exactly the same steps here, which is what I'll be doing here. Okay, so first of all, I define a function. So these are all, of course, let's go ahead and run them. These are all the libraries that I'm going to use. And because we're not training, we're not going to use any keras.layers, none of that, just load model, because we need to load the model and do the prediction. And I'm importing from Pillow image because I want to resize the input image to the size that we used during the training process. NumPy, of course, to handle our NumPy arrays, and label encoder, so I can convert my these numbers into labels and then reverse back into actual labels so I can print it out on the screen. Okay, so these are the classes that we want to label it into, and I'm using label encoder to fit and transform into these. And this is basically encoding these into 0, 1, 2, 3, 4, 5, 6 or whatever. And when we do model.predict, the output is going to 0, 1, 2, 3, 4, 5, so on. And we re-encode that back into one of these. That's the reason why I'm using it. Okay, now the meat of it. Let's go ahead and load the model. So using our load model, and this is the train model. Okay, once that's done, I'm going to define my size as 32, and let's get the image path, because here what goes in is the file name. So image path is, in my case, static is the folder right there. Within static, there is a directory called images. Within images, this is where whatever the user uploads gets stored. These are the ones that I have already experimented with. That's why you have these images here. So normally it would be empty. So by the way, in the static directory itself, if you want to put any style sheets, if you have CSS to style your web page, this is where it actually goes. I have nothing. I like to do things in a simple way for now. You can add styles later on. Okay, so that is what's inside static directory right there. So within the static directory and images subdirectory, go ahead and look for the file name that we supplied and open it using Pillow, resize it to whatever the size, 32 by 32, convert that back into a NumPy array. This is the pre-processing we have done during the training process. So I'm doing exactly the same here. And then divide your image, because right now it is 8-bit, so values go from 0 to 255. So divide it by 255 to normalize, or I should say to scale them to values between 0 to 1. And then expand the dimensions, right? So until this point it is, I don't know, 32 by 32 by 3. We need to expand dimensions by 1, so it is 1 by 32 by 32 by 3, which is exactly what goes into your model.predict. So this is your prediction. So the prediction at this point will be a number 0, 1, 2, 3, 4, 5, or 6. So we need to convert that back into a class name. That's exactly why we have your label encoder.inverse transform, and then go ahead and get the class from here. So finally, once you are done with that, I'm going to print this on the screen. Diagnosis is whatever that predict class is, and that's what it's returning. So I just want to test it out here. So I just did test prediction equal to get prediction example.jpg. So first of all, let's run all of these. Okay, and now example.jpg is exactly what I downloaded right now, and let's run it to see what it gives us. So there you go. Diagnosis is melanocytic nevi, whatever that is. Okay, I think that's what when I downloaded the image was tagged with, but you can test that on your images. And in fact, we are going to test it later on, because these images, yeah, right there, also this is something else. We know that this is working fine. Let's go ahead and comment this. You can leave it open if you want. Now we know our main.py is ready. Okay, so let's get to the next level, app.py. How do I connect my main to app and to index, which is the user interface? Let us delete everything to make sure we start with nothing. Okay, so one of the things that we are going to use here, again, I have some description up here for workzug.utils. We are going to use import secure file name. This is for security reasons. Now you're asking users to upload the files and all that stuff, right? So this means we need to kind of secure the file names so things cannot be hacked in an easy way. So workzug, it provides a bunch of utilities for developing your WSGI compliant, right? So we are working with the WSGI compliant because we are using Green Unicorn, which provides that environment for us when we deploy this into the cloud. I talked about that briefly in the last video, so hopefully this is not a surprise to you. And these utilities, like workzug provides, these utilities do things like parsing the headers, sending and receiving the cookies, and providing access to form data and all of that. Okay, and generating your redirects and a bunch of stuff. And Flask that we're going to use is going to build upon this foundation. If you don't understand any of this, it is still okay initially, so you can just go ahead and run it, and you can look at exactly how I'm using it and update it for your own code. But I just provide high-level description up here. Okay, now let's go ahead and import from our Flask, again, I hope you installed Flask already. From our Flask, import this Flask class that we are going to use to define our app later on, right there, right? We use the Flask class to define the app. Render template is what looks into the template directory, and then finds the HTML files there. So that's what render template is. Request, it's again our web requests. Redirect, as the name suggests, redirect to something. And flash is basically, it pushes these variables to your index.html or whatever the HTML is. We are going to use these again. We'll understand those when we get there. From workzig.utils, import secure file name. Again, we'll see where that gets used. And from main, from this file that we just created, get prediction, import that, right there. Import get prediction function. That part is straightforward, and import OS. Okay, so let us run these. Okay, and now let's define our upload folder. When the user uploads an image, where does it store? We already defined that it's in static/images, so let's go ahead and run that line. Now let's define our app. Let me check if I'm in the right directory. Skin cancer classification. Yes, I'm in the right directory. Okay, so we're defining our app. Again, in the last video, you saw that we had app equal to Flask name. That's it. In addition to that, you can provide additional arguments. Now I am actually providing static folder equals to static, because that's what my static folder is, right? So that is my static folder. Inside the static, again, like I said, it finds the style sheets if you have any, and the images directory, because I'm going to point to that in a minute. So I just defined that. So let's go ahead and create our app object. Now let's do app.secretKey. This is a reference fingerprint. Again, I added notes because this is the first time we're talking about this. Cookies travel with a signature that they claim to be legitimate. And this legitimacy in this case means the signature was issued by the owner of this cookie. And you can type any of these, like I just called it secret key. You can type, hey, this is my super secret key or whatever, something that you only know. Okay, just type whatever that thing is. Because once the cookie is downloaded, others cannot change it. For them to change that cookie, they need to know this secret key. That's the whole point of adding this. Okay, so app.secretKey equals to secret key. And now let's define our upload folder. So app.config or upload folder. I'm configuring our upload folder right here, because this is where our files are going to be residing. So which is nothing but our static images. So we defined that. And now comes the main part that we have looked at in the last video, which is step number 1, app.route. This is the home. And if you look at index, it renders the template index.html. Okay. And again, I added relevant notes, so I don't want to repeat a lot of things that we already talked in the last video. Now comes the app.route with a method equal to post. We talked about this in the last video. When you do method equal to post, that means, okay, fetch the information from the browser, whatever the user provides. So that's what that post is. And it applies this decorator to the following function, which is basically submit the file. So this submit file function is doing bulk of the work that we want to do. So what happens in this submit file? If the method equals to post, which is what we have right there, if file is not in request.files, because when you do this method equal to post, in the last video we saw that request.something, right? So when you do request.files, it should find a file if the user really supplied a file. So if the file is not, then it basically flashes, meaning it pushes that or makes this sorry, and makes this no file part, flashes that, and it returns redirect to where? Request.url. Okay, whatever that request URL is. And my file is basically request.files, whatever that file name is, right? So this is the file that the user uploaded. So my file is request.files, the file name. So far, so good, I hope. If the file is there, this is what we would get. Okay. If the file.file name, if this .file name equals to blank, meaning there is no file, then go ahead and flash no file selected for uploading. That's what it's going to say. So this is basically when the user hits submit or something, it's like, hey, no file selected for uploading. That's what this means. And return redirect request.url, whatever that URL is. Now, if there is a file, right? If we have that file, then go ahead and get the file name. File name is file.filename, but then encrypt it or secure it. That's what this part is. And again, this is a workzug method to secure the file name. Okay, so secure underscore file name. So now we have a file name. Think of this as having an encrypted file name. Now that file name is used to fetch this image and then do the prediction, as you probably know. So first of all, let's go ahead and save the file locally. So file.save, where do you want to save? Upload folder. This is exactly why we defined the upload folder earlier. That's exactly where it is going to save this file name. And once you do that, it's going to run get prediction file name, right? So this file name goes into our get prediction function. If I go back here, the get prediction function, you need the file name. That's exactly what we did here. Get prediction, the file name is example.jpg, or you can call it file path if you want to be technically correct. So get prediction, file name or file path. And our label is basically get prediction, file name. In fact, I don't even know why I have that. I should comment that because I have this line down here. Label equals to get prediction, file name. That was a mistake, by the way. Okay, so let's go ahead and comment that. So my label is get prediction file name, and now I need to flash the label. Just think what we are flashing. So first thing that we are flashing is right there, the label. If there is a file name, the first thing that you will get is the file name. The next thing I'm going to flash is the full file name. The first thing I'm going to flash is the label. The next thing I'm going to flash is full file name. Why? Because when I want to print the label, and I also want to print the file name. Hey, for this file name, this is the label. That's exactly why I'm flashing these two. And full file name is basically that one, right? So whatever the full file name is. And then what do you want to do after that? Go ahead and redirect it to your home page. That's it. So here we're not just sending it to another pages or anything. We're just staying within the home page, but then we are interacting with our main.py in the backend. I hope that makes sense, and you know what if name equals to main means from a couple of videos ago, and then we're running this app. I hope so far it makes sense. Now, methods equal to post. Let's go to our index.html and make some sense out of it. So the title, skin cancer lesion classifier, you know what that is. This is the title of your browser. And then I added this line to make sure that it looks okay even on my phone, which is exactly what I showed you here in my presentation. This screenshot that you see here is basically the screenshot from my iPhone. Okay, so it looks nice on the phone because I have this line. Otherwise, it looks too small or too big. I don't know, depending upon the size of your image and so on. So that's that meta. Now I want my background to be black. I want my text to be violet. What text? Skin cancer lesion classifier, upload an image and click submit, right? Again, let me go back to this screenshot, and you can see skin cancer lesion classifier, upload an image and click submit. This is just static text. And then you have two buttons, one for choose the file, another for submit. And then show whatever happens after you click the submit. So let's come back, skin cancer lesion classifier, upload an image. So this one in a slightly larger font, this one in a smaller font. Now comes our form method equals to post, right? Our method equals to post. And again, encryption type, multi-part form data. This is again, just copy and paste if you want, but this is the important part. Method equals to post. And go ahead and this is the text color, but where is it? This is the key point. Input type equals to file. Previously, we had input type equals to text in our last video, where the user is, where it displays a text box. And then the user types a value in that text box. Here, input type is a file, which means it automatically puts a button for the user to upload an image, or a file, I should say. And then after that, I want a submit button. That's exactly what that input type is, submit. This is a submit button. Once the button is clicked, go ahead and do the following here. What does it do once the button is clicked? Well, when the button is clicked, let's go back. Because there is a method equals to post, first of all, this part gets the file name. Request.files is going to provide the file because we have method, where is it? Type equals to file. It's looking for that file when it's looking for request.files. And that file gets fed here. And this is the backend where it is taking that file and it's doing, where is my model, get prediction, which is nothing but calling this file, and then it's doing model.predict, and this returns prediction class, and that predicted class is what we are going to flash right there. Okay, that flash, we have to display it on the main page. How do we do that? Now let's go back to index.html. Okay, and you can set the color and all that. That's the basic part. First thing first, let's get the flashed messages. If there are 10 messages, you'll get 10 flashed messages. We have, if there is a file, we have 2 flash messages. One is the label and the second one is the file name, right? You can add more. For example, if your main.py, if this returns not just predicted class, but if it also returns the predicted probability, 2 things, then you can actually flash 2 things here. Flash the label, flash the probability, and flash the full file name. Now you have 3 things in flash. In this example, you only have 2. Okay, so keep that in mind. Get flashed messages. If there are class messages, then do the following. Diagnosis for the following image is, so it's going to put a text and then it's going to add, remember our flashed messages, sorry. If there are messages equal to get flashed messages. So if there are like I said, 10 messages, then this is a list of 10 messages. In our case, we have 2. So this is a list of 2 things. The first thing being the label or the printed output, not just the label, but the entire printout, sorry. Diagnosis is, that is the flushed out message. And the second one is the file name, right? So that's exactly what we are doing here. So let me create some room. Okay, so if there are any messages, if there are flashed messages, then diagnosis for the following image is message 0. Remember these 2 curly brackets, and then messages 0, because this messages will be a list of 2. So go ahead and get the first one there. And also go ahead and get the second one, which is nothing but our file name, full file name. This is the path to our file. Why am I getting it? So I can display it on the screen. So how do you display an image in HTML? It's image source equals to whatever the URL is. It can be a local URL, it can be any other URL. In this case, go ahead and fetch this message, and that is the URL, and display that in a size of 300 by 225 width and height. And that's it. And go ahead and if, because we started the if right there, and go ahead and end with, because we started the with right there. If you don't understand this syntax, it's okay. Just go ahead and update this. Now you have a template, you can just go ahead and update it. But I really want you to understand the logic behind each step here. I hope you do now. Okay, so now that we know this, let us make sure we understand everything here. We understand main.py. This is the easy part. As data scientists, we know what this is. And this main.py is imported here. From main, import the get prediction, and that get prediction is used as part of our submit file function that is decorated with your app route right there. Okay, so that's a lot. So first of all, let's make sure all of this is working locally. So let's go ahead and click run, and it gets pushed. Oh, sorry. Yeah, copy. Let's go to our page. Let us paste it, run it, and there you go. It's running locally now. So let's choose a file. Okay, previously we tried this, so let's go ahead and try the capture.jpg. Let's open, and hit submit. There you go. Apparently this is basal cell carcinoma. Okay, so this is working fine. Now hopefully the logic makes sense. This part is very straightforward in your index.html because that is your skin cancer upload, and that has nothing to do with the logic of our deep learning. And the next part, if I open the browser again, choose file, no file chosen, and submit, right? Where is my choose file? Choose file. There you go. So input type is file, and autocomplete is off. I mean, there's nothing there, and this is where it's actually showing you that choose file. And that no file is chosen is coming from this part. In fact, if there is nothing right there as part of this input type equals to file, that is something that it's going to report. What does it say? No file chosen. And the submit button is our type equals to submit, and it just name equals to submit, value equals to submit. That's exactly why it says submit. You can change that to submit your image or whatever. And the bottom part, diagnosis for the following images, and all of this part is coming from this part right here, because now we have an image, and that image gets posted here. And if file not in request files, it is. If file, then the file name, get the file name, go ahead and save that file locally, and create, get prediction and assign that to the label, and flash that label, flash the full file name, and we are using the label to display it up here. We are using the file name to display it on the as an image on the screen. Okay, so far so good. Now let us make sure we push this into our GitHub and then connect it to Heroku. So how do we do that? Let's go here to our GitHub page, create a new repository, and this is skin can. Oh, by the way, in this case, I'm not using Docker at all. Why am I mentioning this? Because you can also use Docker, which is nothing but a container. You can do your own containerization and then still deploy that to Heroku. In fact, I'll do a video on that in the next video will be on that topic, but exactly same application. So hopefully that would be a faster, quicker video. So let's do this skin cancer. I tend to put underscores. Let's just do tutorial. Sorry. My keyboard is hidden under the table and it's tough to reach, but I managed to reach it. Okay, let's go ahead and create a repository. Let's make this private, and let's add a README file and create the repository. And before we push our code, I completely forgot to show you a couple other things. I assume you watched the previous video, but if not, so far we looked at the model. We looked at the static, where the images are going to be stored. We looked at, in fact, let's delete all the images in static. I don't want to upload a whole bunch of stuff to my GitHub. So let's go ahead and do that. And templates, we have our index.html. App, we just looked at it. Let's delete our example. Let's delete our example.jpg. We have our app.py. We have our main.py. So all of this is what I did for the last 28 minutes. Now let's understand these three. I'm pretty sure you know this if you watched my previous video. Runtime.txt, go ahead and define what Python version you want to use. It's Python hyphen whatever the version. I did 3.7.10 because that's what I have on my system right now. And requirements.txt, again, this is basically what libraries you want to be pip installed in that Python 3.7 environment in the cloud on Heroku. So we want, again, do not forget to include exact version number if you want your app to be working 6 months from now, because these guys, NumPy and all of these will be constantly updated, but it's not guaranteed that they're backward compatible. One very important point. If you just put TensorFlow equals to something, it installs TensorFlow with GPU, which is like 700, 800 megabytes, and Heroku will crash, not crash. It will say, I cannot do this because the maximum limit you have, especially for a free account, is 500 MB. Okay, anything that goes around above 500 MB, like in this case TensorFlow GPU itself is going to be almost a GB, then that doesn't work unless you subscribe to their higher end packages where you can do that. Right now I'm defining this as TensorFlow CPU 241. This is okay, this works fine, and CPU is fast enough for prediction anyway. Okay, that's one thing I want to mention. Everything else I think is self-explanatory. And finally, the proc file without anything, any extension. This is just proc file with the uppercase P. If you don't have this uppercase P, again, your program will crash. Your app will, it gives you some mysterious message that you cannot decode. So uppercase proc file. And what is in here? Exactly the same file I have from last video. Web : space gunicorn space app:app. Why app::app? Because my file name is app.py and the app that I created here is called app. That's why it is app::app. Gunicorn, it provides you this environment like I talked to you. Again, Google search for what that is and learn more about it. But this is what we have here. Okay, so with that knowledge, let us go ahead, and our GitHub link is right there, and let us push all of these into our GitHub right there. My H5 file is a bit large, but that's okay. We can upload that, commit the changes. You can push it using your git push, git add, git commit if you're comfortable using git from here, right? Why not just drag and drop? So that's what I have here. Okay, now that I have this, let's go to Heroku, create a new app. And what do we call this new app? This must be a unique name again. So skin cancer tutorial. Skin cancer tutorial is available. Skin cancer tutorial is available. So why not make it skin cancer tutorial right there? So see if the name is available. Create app. App limit of 5 apps. Oh God. Okay. Let me sacrifice a couple of apps right there. Let us go ahead, and if I go to settings, sorry about this, I did not know about this limit. And to delete an app, I just need to copy this, paste, delete the app. Let's also delete the one from last video, HD tutorial, right? Yeah, that's the one from last video, because I don't want people to be using that. Delete app. Nothing wrong with using it. It's just that I don't have enough dynos, or so you'll not have good experience if you want to use that. Okay, so now that we have it, let's go ahead and create a new app. And what did we call this? Skin cancer tutorial. Okay, so skin cancer tutorial is available. Create the app. So hopefully it should create it now. Again, this is blank, nothing in there. It needs code. Where do we supply the code? You can again push it to the Heroku Git, or let's go to GitHub and connect our GitHub. I already connected it under my name, but I did not provide the repo name. So let's go ahead and give the repo name. So that's exactly what we created, right? Skin cancer tutorial digital Srini. Oh, sorry, that's the wrong one. This is the one I should be giving. That's the repository, skin cancer tutorial digital Srini. Okay, search for that on my repo. It found it, connect it. Okay, we are getting there slowly. And there you go. So we connected it. Now I need to deploy it. So let's go ahead and deploy the branch. And it first look for my Python, which under runtime.txt gets that environment and looks at requirements.txt, pip installs everything, and then our app should be ready to run. So it's installing Python 3.7. If I can go back up, installing Python 3.7, and then it's pip installing Flask 112, Workzig 201, NumPy 119.5. This is basically what we have right here, right? So Flask, Workzig, NumPy, it's going one after the other, installing it. And at the end of it, it should hopefully say that the app is ready. So I'll pause this video and continue as soon as this is done, because installing TensorFlow and some of these may be a little slow. Okay, so there you go. It took about 3-4 minutes or so to install this, to get this thing running. And now let's go ahead and hit the view app, and this is our unique URL. Now I can open this on my iPhone if I want. This is skincancer-tutorial.herokuapp.com, and there you go. So that's the app, exactly how we want it to be. So let's see if it's working or not. So choose a file. Let us go ahead and choose the same capture.jpg. Let's open it and hit submit. Internal server error. The server encountered and unable to complete your request. Solve it, overload, whatever. Let's go back and troubleshoot this one more time. Let's go ahead and select this file. Let's do the same one. Let's hit the submit. Okay, now I have no clue what's going on. The server encounter was unable to complete, either the server overloaded. Okay, let's do one other thing. So if I go back here and if I look at resources, it doesn't say any dynos or anything. So let's scale the dynos up by 1 because we don't have any dynos here. And I talked about this a couple of tutorials ago. So let us, what is skin cancer? Can I copy it? Yeah. I just want to copy the name so I don't have to type it. Okay, apparently it's not letting me. Oh, it's a skin cancer tutorial. Sorry about that. It's that one. Let's copy this and let's open our Heroku. Go ahead and log into your Heroku. All you need to do is Heroku space login -i and enter your login credentials and scale this app. And this time our app is skin cancer tutorial. So hopefully it should add a dyno right there, and maybe that makes a difference. I'm not sure. Let us see if that works. Okay, so let us, where are we? Right there. And let's look at resources, reload, and hopefully it should say G unicorn something something, then we are all set. Okay, so G unicorn app. So we know that at least I have dynos right now. So let us go to open the app and see if this works. If not, I don't know. We'll have to do some troubleshooting. Okay, so after scaling the dynos, and again, I hope you know exactly what this is. After scaling our dynos, which is what we just did, so it showed us this green unicorn app.app. I tested this one more time, it failed, right? So all I did was went back to deploy and just deploy the branch. And it redeployed it, and I think it's working now. Let's close this to minimize any confusion. Let's go back. We deployed this. We are in the right app, skin cancer, open app. There you go, skincancer-digitalsrini.herokuapp.com. Let's select a file, and I renamed the file to my test image. I don't know, just to see if that works. So go ahead and submit it. The first time it may be a bit slow, but still with CPU, it's doing a pretty good job. You see how it says basal cell carcinoma. Let's try this on a different file. So let's go ahead and look at that example.com, submit. That's melanocytic nevi. Let's actually test it on a few images I just deleted, because a couple of images we know exactly what they're supposed to be. And then let's end this video, okay? So the one I deleted was AKIEC. AKIEC. I have no clue what that means, but we'll find out. Oh, apparently that's actinitic keratosis. So yeah, that matches the file name. So this the accuracy I'm getting was like 92 to 95. I forgot when we trained it. It was high, mid to high 90s, actually 95 or so. But based on these handful of examples, you can see how it is already working great. So now I can open this in our phone or wherever, and it works great. Sorry for that minor hiccup, but you saw how things can fail and what happens when it fails. So there were no dynos in our example, so I went ahead and scaled the dyno. This is exactly why having the command line interface can be very useful. It's very easy to use. All you need to do is Heroku login -i, and enter your email and password for your Heroku, and then you can just use a whole bunch of commands that you can do with Heroku. In fact, you can create a new app right from here. You can push the code from here, and you can do a lot. But the one thing that I constantly use this for is to scale the number of dynos. Just imagine if you have even more dynos, then you have a lot more power to power up your application. So I hope you found this tutorial to be useful. In the next one, I'll show you exactly the same except using Docker container. So you're containerizing everything and you're just pushing the Docker, and then you create an app on, it's a slightly different process. That's why I wanted to make another video in case you prefer to work with Dockers. So please stay tuned for that one, and like this video, subscribe, tell your friends. Thank you guys.